Hey there, what did the baby corn say to the mama corn? Hey, where's popcorn? Yeah, it's funny. Okay, so we're working on no solution. That's the title of this, and it's the last video in the lesson analyzing solutions. And I can simplify an equation into the form a equals b and interpret the results to indicate that no solution exists. So, up until this point, we have talked about things that have one solution, only one thing for x that would make the equation true. We've talked about infinite solutions for equations, and now we're going to discuss the no solution equations where nothing exists, no real number exists for x that could make it a true equation. So we've covered this and this, and we're going to knock off the no solution here. We're going to review some definitions, and we're going to jump right into some examples. Here we go. Oh, here's your number clue. It's less than 50. Okay, get that down. All right. Remember this, and I showed you this on the last video, single solution equations result in x equals something, okay? There's only one possible solution for the variable. We know then that there's only one solution because x equals something specific, and we end up with the exact same thing like x plus 2 equals x plus 2. Then we know infinite solutions exist because we could subtract 2 from both sides and end up with x equals x, or we could have subtracted x from both sides and ended up with 2 equals 2. Either way, if you have something equaling itself, it's infinite solutions. But notice no solutions are going to result in something where a equals b, or like something, a false statement of 2 equals 3. We know 2 doesn't equal 3. It's a false statement, therefore no solution would exist. Let's look at some that might result in that. All right. Oh, I already had an example here. Skip that. Already gave you an example. This is just another example of a false statement, so we'd say there's no solution. All right, so tell how many solutions exist for the variable. And when it says tell how many solutions, if there's a single solution, you should give the solution. If there's infinite, you should write infinite. If there's no, just write no solutions, okay? So with an equation like this where you have x's or variables on both sides, the first thing you should do is get the variable on the same side of the equal side, of the equal sign, of the equal sign. Okay, so I'm going to show you how to do that. Some of you already know. I'm going to start out by doing that. So I'm going to subtract 2x from both sides, because that would be how I would try to move one over to the other. But notice what happens right away when that happens. I end up with nothing here, because 2x minus 2x is nothing. So I end up with 1, I end up with just 1 on the left-hand side. That's it, just 1. Equaling, and this is 0, 2x minus 2x is 0, 3 minus 4. So then from that point, I simplify, I combine terms, simplify, and I end up with 1 equals negative 1, because 3 minus 4 is negative 1. This is a false statement, so because it's a false statement, I write no solution. In other words, if you have an equation where there's not going to be a solution, the x's are going to cancel each other out. In other words, they're going to go bye-bye. They're going to leave when you try to move one over or subtract them or something, and you're going to be left with a false statement. Let's look at one more. Tell how many solutions exist for this. Well, this one's a little trickier. We have to do distribution first. I'm still going to try to move variables over, so I'm going to rewrite the left-hand side here. Distribute this 2 to both terms like we've learned. So 2 times 2x is 4x, and then 2 times negative 1 is negative 2 minus 3. I'm just going to show you right here real quick. The next line we could, instead of subtracting 4x, we could just kind of simplify this part right here, combine terms here. Negative 2 minus 3 is negative 5. Right away, I know that no solution is going to exist because I have the exact same amount of x's on both sides, but I have a different constant. So watch what happens when I try to get rid of the x. If I subtract 4x from both sides of this equation, these cancel out to 0, so I'm left with just the 5 on this side. On this side, the 4x's cancel out, and I'm left with negative 5. Again, I've got a false statement. So no solution exists. Now, it was just sort of a bad coincidence with my example problems that I ended up on this last problem 1 equaling negative 1, and on this problem 5 equaling negative 5, you could still end up with false statements that aren't opposites. So you could end up with 2 equals 3. That's a false statement. That would be no solution. It won't always end up being like 5 equals its negative version. Sometimes you'll end up with totally different numbers. All right, one more problem, then we're done. This problem, I don't know how many solutions exist. Let's find out. But I can tell right away, because there's a different amount of x's, that there's probably only going to be one solution. So I'm going to begin by subtracting 2x from both sides. I'm going to put my x's on the right-hand side this time, just for fun, just to show you that you can. So these cancel out to 0, so I'm left with 12 equals 4 plus x, because 3x minus 2x is just 1x. Okay, so that's where I got my x. Now I'm going to subtract 4 from both sides, because I want to get rid of this 4. So that gets me just x on the right-hand side, and this equals 8. So in this particular situation, there's one solution, and I would write one solution where x equals 8. It doesn't matter if the x is on the left or the right, it still equals 8. That's all there is to this, guys. Best of luck to you. I know you're going to do great.